Hello guys. So from today we are going to start another very important series that is related to the Python and NumPy for MATLAB users. Okay. So in previous sections and in other series we have seen different uses of MATLAB in which MATLAB has been seen to deployed for plotting purposes, for mathematical calculations and computational purposes as well. Okay. But there are some very important drawbacks which are related to the MATLAB, and what are those? MATLAB is not a language, but it is what? Not a programming language. Okay, but that is a package which is developed by the MathWorks for the numerical computing and plotting, etc. Similarly, another very important aspect or drawback of it is that MATLAB is not free. Okay, basically the license you have to buy for the MATLAB is not free and you have to pay for it to the MathWorks. Okay, similarly another drawback it has is it is very slow. Okay, so most of the computation you have to perform in the modern times required a lot of speed, and MATLAB cannot do it because of the computational expensive operations it has to perform. Okay, so these are basically some of the disadvantages. Similarly, another very important aspect of it is not open source. Okay, so what is basically the open source? Any software, any programming language which is open source, a user can basically make changes in its source code and publish it into the library of that language, which can be deployed for the future purposes as well. But there is nothing like it in the MATLAB. Similarly, there are also many other alternatives of the MATLAB, just like the Octave, etc. But it also has some of the disadvantages which it has, like Octave is free to use, but it is also very slow and also has very limited accessibility to most of the packages which comes inbuilt with the MATLAB. Okay, so therefore it doesn't give that much advantages as the MATLAB. Similarly, in recent years we have seen the uses of MATLAB, and most of the people which were previously using the MATLAB are now converted to the Python because of the extensive community the Python has. Okay, so this is basically the advantage of the Python, which is over the MATLAB. Similarly, another very important advantage it has is Python is a full-fledged programming language. Okay, that is a programming language, and also Python is open source. Okay, similarly there are many data structures in it which are slower than most of the other data sets, just like lists, which are somehow slower, but the alternatives of lists are basically arrays, which are faster. Okay, similarly, if you see the uses of Python, it also uses the computation powers of the GPUs. Therefore, Python is of higher speed than that of the MATLAB. Okay, similarly, most of the packages which are in use today are usually written in Python, and most of the libraries in the data science, machine learning, deep learning are usually in Python. So this is one of the major reason of the higher adaptability of the Python as compared to the MATLAB. Okay, similarly there is a package here which is called the NumPy. So NumPy is usually used as an alternative of the MATLAB in Python because of its capability to perform numerical computing. Okay, so let me write it with this blue. So numerical computings. Okay, so NumPy is for what? NumPy is one of the package which is used for the numerical computing in Python. So NumPy is usually used as an alternative of the MATLAB. So in this course, what we are going to see applications of the NumPy which can be used in Python as an alternative of the MATLAB. Okay. Similarly, we have some more other packages in which one of them is the Matplotlib. Okay, and it is used for plotting purposes, and we will also see the we will also see the comparison of MATLAB and Matplotlib as well. But before it, we will dive into the details of the NumPy and MATLAB and see what are the advantages and what are the coding benefits each of them will provide us. So that is the start of this course, and this was our first lecture in which we have used writing pad. But from the other lecture, we will dive into the actual coding and see the differences between the NumPy and MATLAB and see who is the winner. Okay, welcome back guys. So this is part second of our course, NumPy versus MATLAB. So the first thing here is the installation of both the packages, that how easy it is to install the MATLAB and how easy it is to install the NumPy. Okay, so in order to install the MATLAB, what we have to do, first of all, we have to visit mathworks.com. okay, so that is the mathworks.com, and in order to install it, as I have previously told you, that the MATLAB is not a free version and you have to pay for the license, and then you have to put the license key inside the installation wizard. Okay, so that is the mathworks.com, and in order to get the MATLAB, what you have to do, first of all, you have to log in here. So in order to do it, first you have to click or get MATLAB, and then you have to create your account. Okay, so once you will create your account by using the email address, and then you can basically order the MATLAB from where. So here, after signing in, what will you do, you have to get back here into the product, and here you will see that different products are available under the umbrella of the MathWorks. Okay, so that is the MATLAB. You can click over here and then you can get MATLAB. Okay, so there is also a tutorial available for it as well. Okay, similarly, you can also download this trial version from this tab here. So after clicking over here, what you will get the trial version, but for all of this you should have a working MathWorks account. Okay, similarly, there are other toolboxes here. You can basically get them from here by paying some more bucks, and you will use these things here. So after getting the MATLAB, what you have to do, you have to install it. So that would be a very hectic process. It depends upon the system you have, the PC you have. So installation usually takes 25 to 30 minutes, and you have to put the license key and then it will start. Okay, contrary to that, in order to install the NumPy, what we have to do here, I have installed this VS Code environment, and if you want to know about the VS Code environment, how to install it, how to get it, what we have to do, you have to get back here. Okay, in your Google you can type VS Code. Okay, VS Code, and after Visual Studio will appear here, and from here you can download it very easily. That is a free version. If you are a Windows version, you can download it from here. From the other operating systems, these are also given here. Okay, so this is a very easy process of installing it. No money is required, no nothing is required, just you have to download it and then you will have to install it. After installing it, if you have the NumPy, it's good. If it doesn't have, so you can use 3 different package managers. So either you can write here pip install NumPy, okay, or you can also use conda install NumPy. So after clicking here, here, so it will install here. Okay, so that is the terminal. If you don't want to do it in the terminal, what you can do here, you can write here the pip, as it is already installed, so I don't have to install it again, but as it is saying that it is already installed. Okay, so despite having conda here, you can also use pip or mamba as well. Mamba is the latest version of the conda, which is faster than that of its predecessors. Okay, so that's it for the numpy. So in order to see that whether the numpy is installed or not, so in order to do it, you have to import numpy as np. Okay, so if it works, you will get to know that okay, that is working. So this sign means it's working, so it means that numpy is already installed. Welcome back, guys. So now we have installed the VS Code and MATLAB as well. So that is the MATLAB and that is the VS Code environment, and here we will see that how different these are from each other. Okay, so here this is the MATLAB. In order to do any operation here, what we can do, let me add 2 plus 2, and just pressing enter, it will give me 4. Similarly here, what happens here is that here just writing 2 plus 2, it would also give me 4. So there is no difference in between them, but there is only one difference, that by default it is basically stored in the built-in variable, that is the ans, while here we have no variable here. So that is the sole difference here. Similarly, in order to use different operations here, what we can do here is that we have to write any numbers. Like if we have this a equal to 5, so we can just press enter and it will be stored inside of it, while here we can use also the same procedure, and just by clicking over it, and in order to print it, what I can write here, I can write here this print a and it will print it, while here in order to print it, what we can do, we can use a command here, that is the disp, and here writing this a, it will display this 5. Okay, so here printing and here displaying is used. So now, as both of these versions uses the matrices and arrays or vectors to perform their operations, so in order to create any vector here, what we can do, let me give it a name b, and what we can do here is that just we have to give it the numbers like 1, 2, 3, 4, and we have to close it. So just by writing it, it will give me the answer, and if I want to print it, similarly the same procedure. Similarly, in order to elaborate it some more, we can also do it by b is equal to 3 space 4 space 5 space 6. Okay, so the same procedure can be replicated by using the space instead of these commas. While here in the Python, what we have lists. So lists were basically covered in my previous videos, and I will also put the link of that in the description box. So in using lists, what we can do here, that we can use let me have this list b, and here I can use the same thing like 1, 2, 3, 4 as well. Okay, and just by doing it, what I can do, I will have to print it, and printing it, I will get 1, 2, 3, 4. But in NumPy, we are not going to use the list. So what is the reason? That in conventional MATLAB we are using the list, but in NumPy arrays are used. So NumPy arrays are basically faster than the lists and have many operations which are customizable, which are optimized to use for many applications, just like data science and many other things as well. Okay, so similarly, now if I want to access any number here, so suppose if I want to access the first number here, that is 3, what I can write here, I can write here b1. Okay, and just by writing b1, I can see that the first number is, I will get this first number. While here, in order to get the first element here, I have to use these square brackets, while here I have used these common brackets. So now writing the index here, what will happen, it will give me 2. So you can see that this is not the first element while this one is the second element. What is the reason behind that? So as I have previously told you that Python is a full-fledged language, so therefore the indexing here starts from 0. So if I will write 0 here, so 1 will be displayed, which is the first element. So that is about the indexing, which is different in between the MATLAB and Python here. As we haven't now have gone to the NumPy, so we are just introducing you to the concepts of the list and the MATLAB as well. Similarly, there are many other operations, and I am also going to put the link of that operations, which are the list operation, in this video, and also different operations of the MATLAB will also be included as a link of this video. So from the next video I will show you the differences and common points between the MATLAB and NumPy, and from the next video I will start the NumPy package from the very beginnings. Hello again. So recently we have started a series in which we are going to discuss the differences and similarities between the MATLAB and NumPy. Okay, so as I have previously stated, NumPy is one of the most important packages which is recently used as an alternative of the MATLAB due to the fundamental advantages it offers in the recent years. Okay, so today we are going to use the NumPy. So in order to use the NumPy, as I have previously told you that in order to use different packages in MATLAB, which are called here the toolboxes, and in order to access those toolboxes, what you can do here is that you can click on it and you will see that we have different toolboxes available here. Okay, so in NumPy, if you want to use different toolboxes which are called the libraries or packages in the language of the Python, what you can do, as I have told you, that first you have to install them by using the pip install, conda install, or the mamba install. So after it, what you have to do, you have to import them. Okay, so as NumPy is previously installed, so I can import NumPy here as well. Okay, so what I can do here is that I can directly import NumPy here, but it is not a very good practice, because once it is imported, you have to import it as some variable. Okay, so I can write here np. Why np? I can write any other variable here as well, just like npy. So if I will run it, it will run smoothly. But why np? Because that is the variable which is commonly used in between the NumPy users and inside the community, which is extensively available over the internet. Okay, so I have to import it, and after importing it, what I can do, I can perform different operations. So as I have previously seen that in order to create any NumPy array, what I can do, so let's have the array here, let me call it AR, and what I can do right here, np dot array. So once you will write dot here, so in many IDEs you will see that different functions or the methods which are related to my package will be shown here, just like the auto suggestion. Okay, so what you have to do, you can write here array. Okay, so after array, what you have to do, you have to use these brackets for the methods, and inside of it you have to use these square brackets, and inside it you can write like 1 comma 2 comma 3 comma 4. So it is mandatory to use these square brackets here and also these curly brackets, because it shows the function here. Okay, so now let me run it by pressing shift enter. Okay, so it is now run, and if I want to print it, what I can write here, I can write here this, and it will show me that that is the array. Okay, what if you will not write these square brackets? So writing it, it will give you this error that it is not basically the fundamental operation here, so you have to put them here as well. Okay, so it is mandatory here. Similarly, if you have any list which we previously discussed in our lecture, so let me have that equal to b, and let me have it here 3 5 2 6. Okay, so let me have this list, and if you want to convert it to the array, what you can do, so let me first check this type. So bb, the type of it is list, and let me change it to the array. So arr is equal to, what you can write here, you can just like here np array, and here you can write this bb, and just printing over it, what I can see that it will be the numpy array. You can see that these will be the same, but checking the type of it is, now this is the numpy nd array, okay, n dimensional array. So you here the dimension is 1, so therefore it is showing me nd array. Similarly here the procedure remains the same as we have previously discussed. So I can use 1, 2, 3, 4, or I can write here 2, 3, 4 as well. Okay, so if I'm not putting the semicolons at the end, what will happen if I will press enter, it will be the same array will be shown here. So it is now here. So the fundamental operations will remain same, but here the thing is that if I want to check the size of it, so let me check the size of bb. It is 1/4. Okay, so 1 row and 4 columns. Similarly here, in order to check the, what I have to do, let me move here, and np dot size, and that is of this. So it will show me that the size of it is 4. If I want to check the shape of it, it will show me that it is the 4 comma any number of columns here, because columns are not defined, but that is the n dimensional. So in order to reshape it, let me have, this is array is the, this basically contains 4 elements. So if I want to convert it to the 4/4 array, what I can do here is that, let me have here array underscore new, and let me write here np dot reshape. Okay, and here I have to write ar, and inside of it I have to write here what 2, 2. Okay, and here we have this one. So let me print it now, and it will be now ar underscore new. What will it will be? So you can see that the size of it is now 2/2. Okay, or I can also use np dot shape. Okay, so it will show me that this is basically 2/2 array. Similarly here, what I can do here is that there is only a very important command, that is the reshape. Okay, so let me write here arr here, arr here, and reshaping which vector here, so that is bb, and reshaping it to the 2/2. Okay, what will happen here? So it will be this 1, 2, 3, 4. Okay, so you can see that here the fundamental difference is that first row is converted to the first row of it, while the second row of it is converted to the second row of my newly constructed vector. While here you can see that this 1, 2, the first 2 elements were basically combined as the first column, while the second or last 2 elements here were constructed as the columns of my matrix here as well. So while adopting the NumPy, you have to keep these things in your mind. Okay, so this is all about the reshaping. Similarly, what about the indexing? So indexing remains the same. If I want to access the first element here, what I can write here, I can write this 0, so it will show me the first row of my array, which is here. So what if I want to access the first element here? Okay, this is basically what this is 0, 0. So if I want to access this element, this is the first row. So if I want to access it, what I can write here, I can write the 0, 0, and it will show me that this is this one. Similarly, if I want to access this second element, which is the 5. So what I can write here, I can write here 1. Okay, so it will show me 1. Similarly, what if I want to access this last element? This is in the second row, second column, so I have to write here this one. Okay, while here what I have to do, this is array. Okay, so this is 0, and printing it here, it will not work. Why it will not work? Because I have previously told you that 0 is not the index which is used inside the MATLAB. So what you have to do, you have to write here 1, so it will show you that it is 1. Okay, so it is not showing you the first row here, but the first element here. Similarly, what if you want to see this fourth element? You just have to write add and 4 here, so it will show you that this is the fourth one. So now that is the procedure inside of it. What if you want to see this first row here? You have to write here array and here from 1 to 2. Okay, so writing it here, you will see that the first column of it will be denoted. So that is about it, and I have also shown you the benefits of this colon operator in my previous in the video which was related to the MATLAB. What is this colon operator? There is also another functionality of it, and let me use that functionality. If you want to create an array or vector which starts from, so let me first clean it, which starts from 1 and goes to 10, so you can write here 1 to 10, and just by clicking over it, you will see that an array of 1 to 10 has been created. What if you want to create the array in which the difference, which starts from 1 and has a difference of 0.2 and ends at 3, so you will see that it will start from 1, then 1.2, 1.4, and will reach up to 3. Okay, so that is it. So if you want to see the length of it, you will see that here tt, and it will show you this 11. What is basically the alternative of it in the MATLAB? So in NumPy we have seen the uses of range. So if you have range, so if it starts from 1, okay, and ends at 10 with the difference of 1, so what you have to do, this 10 will not be included, therefore you have to include this 1 as well, and at the end you have to write the differences between the first and the last element here, so it will be created, and you will see that this is the range. But in order to save the computations, what it does is that it doesn't create the 1 to 10 elements, but it stores like an object. So if you want to create the elements here, what you can do here is that you have to use the command here for I in range of 1, 11, 1. Okay, or you have to print them here. Okay, so what will happen here, you will see that all the elements from 1 to 10 will be printed here. Okay, so you can see that here this is the difference. Similarly, what if you want to create the element from 1 to 3 with a difference of 0.2 as I have here created? What you can do here is that you have to write the first element, then the second, and then the last. But in order to print them in the range command, you should have to iterate it by using this for loop. So you will see that while writing 0.2, it cannot work because the difference between any two numbers cannot be 0.2, so float numbers are not acceptable. Therefore, so just you have to write here, let me write here the 3 up to 1, and what difference would it have? It will have -1, so you will see that it will start from 3 and will reach up to 1 plus 1, so that is 2. Okay, so that is it. Similarly, in NumPy there is also another command, that is the a range. Okay, so if you want to create, let me have an array a and np dot a range. Okay, and here you have to write the first element here and then the last element and the difference between them, okay, which is this one. Okay, so this is a and printing it, what you will get you will get that all the numbers are suddenly appeared as we have done here. This is the sole difference between a range and range. Okay, so in range all the elements are created but not shown until and unless you invoke them by using this for loop, while in a range all the elements are suddenly created. Similarly, if you want to create them from 1 to 3, 0.2, okay, so you will see that previously there those numbers which were having 0.2 were not created because it basically had those differences which were in the float numbers, but here it can create all those numbers as well. Okay, so this is also a very important functionality, and here we can see that the same array has been created which was created here as well. Similarly, another command here in MATLAB here is the linspace. Okay, so if you have the another array just like double a equal to linspace, okay, so what you can do, you have to create 10 numbers in between 0 and 1. Okay, so this is the first number while this is the 1, while at the end of it you want to mention the number of elements you want to create in between 0 and 1. So just you have to write them here. Okay, and just clicking over it, you will see that from 0 to 1 10 numbers are created. Now similarly, the same command is also being available inside the NumPy, and the same command and the same name is given it to it, so that is AA, and here np dot linspace. Okay, you can see that it is already available here. Okay, what you have to do, you have to write the first element which is 0 and then the last element here, and at the end of it you have to write the number of elements you want to create in between this range. So 10 numbers here, so writing them here and just printing them over here, you will see that all the numbers from 0 to 1 are created, which are basically the number of elements which you have mentioned here. So the same command which is used here are also available here. Okay, similarly some more uses were also being shown as I have mentioned them here. So these are the sole differences and the similarities which we had here in between them. So that's it for today, and I will see you with some more example and some more interesting aspects of the both of these versatile softwares or packages in our upcoming videos. Welcome back guys. We were discussing some very important commands in the MATLAB and NumPy and what is the difference between them. So suppose again we have this T here, which is an array which composed of the numbers from 1 to 10, and in order to find the sum of it, what I can write here, I can write here sum of t. Okay, and now here storing it inside this s of m, and just by clicking and writing it, what I will get the sum of it. Similarly here, if I have a equal to np dot a range, okay, and it starts from 1 to 10. Okay, and here in order to find the sum of it, just like we have done it here, what I can do here in NumPy, we have a command that is np dot sum, and in order to sum it, what you can write here is that you have to write this sm, and printing it, what you will get that this is s of m. Okay, why is it? Because the summation is now not in between 1 and 10, but it is in between 1 and 11, because I have previously stated that this is the result of the elements which starts from 1 up to 10 minus 1. So what you have to do, you have to write here 11. Okay, so now it is an array of from 1 to 10. So now printing it, and you will see that the same results are now obtained. Similarly, what if I want to get the results along the y-axis or the column axis? What I have to do here, I can write here the axis, and 0 axis means I have to add all the elements row wise. So writing it here, you will get this one, and similarly writing it like this one, you will see that you have to add all the elements column wise, because here printing a will give you what? This will give you the row matrix. Okay, this is basically the row matrix, and adding them column wise is not going to the results which are intended. So therefore it is not giving me the results, but this is the error it is showing me. So therefore I have to add them. Okay, so that is about it. Similarly, here in this command, what I can in MATLAB, I can also do it. Similarly, in order to multiply the elements, what you can do is that you have to multiply them, and I will show you the multiplication of different arrays in our upcoming video, because that is the very important aspect of the NumPy, which will show you different multiplications and aspect of it in the optimized way. Similarly, some other built-in vectors here are here. What are those vectors? So let me have here zeros. Okay, so zeros here are basically, let me write the size of it. So 2 by 2. Okay, so this will give me this 2 by 2. Similarly, here z is equal to np dot zeros, and writing here 2 by 2, it will give you what? It is not going to interpret it. Why? Because I have to put these square brackets here as well. So it will give you this zeros. Similarly, if I want to get these ones, so writing them here as O. Okay, and here this will be ones. Okay, so printing it, it will give me this one, while this one here will give me O equal to ones. Okay, again writing them here, and 2 and I have to write here np. Okay, sorry, I forgot it. So here, and printing it, I will get this one. So it is now ones. Similarly, another very important matrix here we got is this I. Okay, so I is what? That is the identity matrix, and as this is a square matrix, so I have to write here this 3. So this will be square matrix in which the diagonal elements will be 1. Similarly, here in NumPy, what I will have this np dot I, and writing the dimension here, and then printing I. Okay, so it will give me the same matrix. Okay, these are all the matrices which are built in inside of it. There are also some other matrices, and you will see the official documentation, but these are basically the similar matrices which are used here. Similarly, if you want to construct another matrix which is of the same size as that of it, so you can also use some other matrices which I will explain in our upcoming video.